Hello, this is my lab 3. So just an introduction of the lab. We wanted to find the mass of a black hole with a theoretical scenario that we were given, and we also wanted to determine the velocity of a rocket ship if it was trying to orbit around a planet by the black hole and the planet's moon. And some of the physical principles we used were the force of gravity, not on Earth, but in space, created by objects on objects. And our main result was that the mass of the black hole was 6.8 times 10 to the 94 kilograms, which is obviously really big. And our initial velocity was a negative, really big x value and a positive, really big y value, where the y is bigger than the x, or the magnitudes. So some of our main ideas were the force of gravity equation, which you can see there, and we used that to find the force of gravity from the black hole to the ship, to the planet, to the ship, and all of that, and all those different combinations in our code. And then we also used the FNet components of perpendicular force and parallel force to find how our velocity would be affected and how our direction would be affected. So for our experiment, our system is a star and the surroundings are the black hole. For part 1, our initial conditions were listed there, and we coded to update FNet on the star using momentum, and we used the force of gravity equation to find the mass of the black hole, since we knew the FNet would be the F gravity. And then we averaged all the masses that we found through the iteration in the starter code to get the actual mass of the black hole. So this is our code. These are the things we changed and the things that we coded to update everything. And so our result of that was that mass of the black hole. And for what it means, the rate of change of momentum is equal to net force. Additionally, the parallel and perpendicular components of momentum's rate of change corresponds to the parallel and perpendicular components of the net force. So for our second part, our initial conditions are listed there, and we put that into our code, into the starter code. And then we calculated all the force of gravities acting on each object. So the planet to the moon, the planet to the ship, and so on, to model our experiment. And then we tested different velocities to see which would result in our ship not crashing immediately and not crashing during the 700-hour orbit of the moon. So this is the code that we did with everything edited. And then this is the output of the code after the 700-hour orbit was over. And you can see that the orbit isn't really a steady circle, but it did orbit both the planet and the moon without crashing and lasted the whole 700 hours. Okay, so our results are that velocity that I mentioned earlier. And to answer the what if question, the black hole would be the biggest force on the others because it has the biggest mass. And from the force of gravity equation, we can determine that if it has the biggest mass, then it'll have the biggest force. So the motion of the other objects would mainly revolve around the black hole. Okay, that's it. Thank you.